Hello, physical science students. Today's material is going to cover the evidence of tectonics. And if you look at a topographic map of the world, so this is one that just shows us the different elevations. So you can see really high elevations here versus lower elevations, etc. You can see evidence of tectonics right there. Because I could go and I could draw in here in red. I could draw in plate boundaries because you see along this eastern edge of the Pacific, you've got one plate which is heading in this direction underneath the other plate which is right here. So you have a convergent boundary, and that's what gives us all of these different mountains right here. But what I really want to talk about is some of the very first evidence for plate tectonics, and that is what's called a spreading margin here along the Pacific. Now, this is an area where the two plates are moving apart. So what happens is that if you look down here in this picture, as these two plates move apart, magma is going to come up and form brand new crust in this area, brand new lithosphere, as these two move. And when it does, this new crust has iron minerals in it that then align themselves to the poles. So you can imagine the Earth having a north pole here and a south pole here, and over time what will happen is that these can actually flip. You can get a flip in polarity in these. So as more and more crust is created at these spots, as these two plates move apart from each other, you'll see that the iron grains will align themselves in one direction according to the magnetic polarity of north and south. And then when you get a flip of the poles, they'll then align themselves in different directions. So what happens is you make these bands, okay, that are symmetrical and about that spreading margin there, so that these rocks are paired together on either side of the ridge. These rocks are paired together. These are paired together. So they have both the same age and polarity. And that's one of the ways that we were able to figure out that this dates back even to World War II, when boats were going along this area, and they started noticing these symmetrical changes in the polarity of the rocks when they'd drag a magnetometer behind the boats, that would then tell us that these two rocks correlate on equal distances away from this margin. So if you look here, color-coded, and you'll see this in the CK12 reading, you can see the different ages of rocks that are the same. So like the green rocks here are the same age as these. This blue band is the same age as this blue band here, and they'll have both the same age and the same polarity. So this is large-scale evidence of tectonics. But you can even see evidence of tectonics in your everyday life. Now, this is a picture that I took at Seavey's Landing in Scarborough, where if you look at these cracks in the rock right here, you'll notice that there's two cracks like that. I used the wrong button. Two cracks like this. And there's another crack like this. And you can see that these were actual places where there was pressure put upon these rocks, where when two plates were put together, were smashing into each other, this rock broke as a result of that stress, and it broke in a brittle fashion. So when you go to the Maine's rocky coastline and you see it all broken up in big blocks of rocks hanging off from the cliffs, that's actually evidence of tectonics as well, because these rocks used to be under stress, from great stress from plates colliding. And just a warning, if you ever go on a nature walk with a geologist, watch out, because as I was taking these pictures, my poor son got mired in the mud here. He's all right, we got him out, but, that's the price you pay for science. Hope all is well. Take care.